See, yesterday we just discussed about what are fundamental quantities and what are derived quantities. We also tried to define some of the fundamental quantities. So, just once, can you name the fundamental quantities?
So,
Yeah, can you name the fundamental quantities?
the length, time, current,
Hmm.
temper
Length, time, current, and
temperature, current,
hmm,
luminous, luminosity,
okay. So these were the units which we studied. You can see here. We have studied for length, mass, time, temperature, amount of substance, electric current, luminous intensity. Okay, so these were the seven fundamental quantities which we studied. So apart from this, there are some supplementary quantities which are provided. Those are for measuring the plane angle and solid angle. So we'll discuss them also. They are of quite importance. See, also I would like to bring your attention, all of your attentions to this point that if you observe the symbols of the SI unit, okay, if you observe the symbols of the SI unit, some of them you find in capital letters and some of them in small letters. So there are only two units which are written in capital letters. You can see Kelvin and Ampere. They are the units which have been written in capital letters. All others are written in small letters. Okay. So for time, second is written as small s. For length, meter is written as small m. Mass is written in kg. Small everything. Only these two, Kelvin and Ampere, they are written in capital letters. So these points need to be taken care while writing the units. Then I'll be discussing about the plane angle and solid angle. So here, angle measurements. Okay. So what are the different angle measurements? Okay. So up to now we have studied the measurement of the angle. How do we measure the angle? Yes. What is the way? How do we measure the angle? What are the units for measuring this angle?
in degrees,
Degrees. We measure the angle in degrees. So this is a sextant method which we use. That there
Hello. Hmm.
okay. So see, we were discussing the measurement of
Okay,
angle
sir.
in. So 1 degree is equivalent to 60 minutes. So that means 1 degree can be divided further into 60 parts, and each part we will call as 1 minute. And each minute would be equivalent to 60 degrees. So this measurement we call as the sextant measurement. Currently, we do not use degrees. Instead of degree, we use radian measurement of the angle. So we say radian measurement. So let us see how we define the radian measurement and how different units can be measured over here. Different angles can be measured in terms of radian. So radian measurement, in radian measurement, we find out the angle as the ratio of length of arc to the radius. So suppose you have this. Suppose let this be the radius, and you have the center over here O. Your center is O, and now so suppose I'm making this angle. Now see how what will be the value of this angle in radian measurement. If this is the radius, so the part AB, I'll call this part AB, the circumference part AB, the part of the circumference which is AB. This we call as the length of arc. So this is your length of arc denoted by the symbol L. So the angle in radian or radian measurement of the angle is given by theta is equal to length of arc divided by radius. Okay. So if length of arc is equal to the radius, so your angle will be equal to 1 radian. That angle we will call as 1 radian if the length of arc is equal to the radius. Okay. So in this way, there are if you observe, length is also measured in meter, radian is also radius is also measured in meter. So overall, it does not have any dimensions, but its SI unit is in meter. SI unit will be radian. So this is the radian measurement of it. Now let us try to find out their equivalents in case of degrees. So suppose you have length of arc by radius. So we know that for a 360 degree, it will be making a complete circle. Okay, so I can say for complete circle. So for complete circle, we know that angle in degree would be equal to 360 degree. Okay, and let us see what that angle will be equal to in radian. So for complete angle, what should be the length of arc? If the radius is r, so the length of arc should be equal to the circumference, which is 2 pi r. Am I correct here? That if you take this complete one round, so the length of arc would become 2 pi r, which is the circumference of the circle, right? And if you divide this by the radius r, so you will get the value 2 pi. Now this value 2 pi, this is your 2 pi radian. So that means one complete angle in radian is equal to 2 pi radians. Right. So if you measure the angle in radian, the complete angle would be equal to 2 pi radian. And what this angle is equivalent in degrees? 360 degrees?
360.
Yeah. So we can say that we can say something like this, that 360 degree would be equal to 2 pi radian. Okay. So I can also say that 1 degree would be equal to, this is radian. So 1 degree would be equal to 2 pi over 360 radian. This is also equal to pi over 180 radian. Now you can easily convert. Suppose I want to find out 30 degree. So what would be the measure of 30 degree in radian then? See, 1 degree is equal to pi over 180. So what would 30 degree be equal to?
30 into pi by 180.
Yeah, it would be pi over 180 multiply 30. Okay. And clearly, if you cut it, you will see pi over 6. You get a pi by 6 radian. So mostly we will be saying pi by 6 radian. Instead of talking 30 degree, we will say pi by 6 radian. Right? If you say 60 degrees, so 60 degree would be equal to how much? Quickly perform the calculations in your paper.
Pi by 3.
Yeah, it would be pi by 3. I'm not getting answer from other people. Pritam,
5/3.
yeah, everyone is supposed to calculate and quickly answer. Okay, Pritam, Vedika, everyone. So what if angle is 45 degree?
45.
Yeah,
Pi by 4.
do it on paper, everyone. It's pi by 4. Okay, it will be pi by 180 multiply 45, you'll get pi by 4. Similarly, you get 90 degree, and that 90 degree would be equal to pi by 2. Similarly, you get a 180 degree. So 180 degree would be equal to pi radian.
45.
Okay. So got all the radian measurements of the angle.
Hmm.
Okay. So here I can list out all of them. If you have 30 degree, so 30 degree in radian is equivalent to pi by 6. 45 degree in radian is equal to pi by 4. 60 degree is equal to pi by 3. And 90 degree is equal to pi by 2. And 180 degree is equal to
5.
pi. So similarly, you can change any of them. You should basically know how can we convert from degrees to radian. As see, most of the time now we will be using radian instead of degrees. So slowly we have to shift from degree measurement to the radian measurement. So in this way, we will be measuring our plane angle. So this angle, whatever we were measuring, this angle was the plane angle, right? So in the same way, we can measure a solid angle also. So what we mean by a solid angle? So let's try to see or try to visualize a solid angle. Okay, can anyone imagine a solid angle? And why do we need a solid angle? See, everything, all the things around us, they are in terms of solids. Okay, so all the things around us, they are solid angles. They are not the plane angles. So we need to study the solid angle also. For example, if you take up a cone, okay, so if you draw a cone something like this, so here you are drawing a cone. So when I draw a cone in two dimension, I observe a 2D. I observe over here a two-dimensional angle, but in reality, this is a three-dimensional. If in reality you have a cone, so you will observe that it is a three-dimensional angle. Okay. So the same way as we had defined here, as we had defined for the plane angle, that it is given by the length of arc divided by radius. So length of arc divided by radius would be equal to angle measurement in degrees. So in the same way, solid angle measurement is also defined. Let this be the solid angle. So this solid angle theta, also called as T radian. So this is measure solid angle will be measured in T radian. Okay. So how do we find out T radian angles? So a T radian angle or theta would be equal to area of the circumference. Area of this curved surface. So it is area divided by r squared. So this area divided by the radius squared is given as angle in radians. Okay. So got the angle measurements. Okay. So let us say after this, what all other things we have. Now in the CGS system of units, CGS system of units means centigram, meter, second. So CGS, centimeter, gram and second. So those units are called as the CGS units. Sometimes we may need to convert from CGS unit to SI unit, and sometimes we need to convert from SI unit to the CGS. Okay. So let us see how do we perform the calculations. To convert from one unit to the other unit, we use the formula N1 U1 is equal to N2U2. Now, what these different things mean? N1 means the number of times of first physical quantity or first unit, number of times of first unit, and N2 is the number of times of second unit. Whereas U1 and U2, they are the units themselves. So U1 is the unit in one of the system of measurements. U2 is the
So,
unit in the second system of measurements.
so N2 is N2.
Yes,
So, what is N2?
see, N2 is number of units or
Okay.
number of times. See what it simply means. If you observe measurement of a length, okay, suppose I want to measure this length. So to measure this length, either I can use meter or I can use centimeter. Okay. So if I'm using a meter, so let us say it comes out to be 2 meter. It comes to be 2 times of a meter. Okay. So if I write 2 meter, 2 meter means 2 times of a meter. When I write 2 meter, so 2 meter, it means 2 times of meter. Similarly, if I say 3 kilogram, so it means 3 times of
10 of
kilogram.
kilogram.
Yes.
Yes.
Yes, Pritam, were you asking anything?
No.
Okay. So 2 meter means 2 times of meter. 2 kilogram means 2 times of kilogram. In the similar way, you can suppose instead of this meter, I'm using foot. So I will be saying it is something. It is equal to 6.2 foot or 6.2 feet. Now I'm saying. So this is 6.2 times of 1 feet. So both the quantities, they are measuring the same units. They are measuring the same physical quantity. So you should have 6.2 times of feet should be equal to 2 times of meter. This is what it actually means when you are writing N1 U1 is equal to N2 U2. So N1 means the number of times the first unit occurs, N2 means the number of times the second unit occurs. Okay, where U1 and U2 are the units. So let us try to convert this with one of the examples, and let's see if you are able to convert this. So here you are given a question. You can observe how many dyne centimeter are equal to 1 Newton. So you have to find out that how many dyne centimeter are equal to 1 meter. This is the question. Okay, so how many of you can convert? Can you convert dyne centimeter to Newton meter?
No.
Okay, see, use this formula N1 U1 equals to N2 U2. Okay, take here N1 to be, let this be Newton meter, U1 be Newton meter, and let U2 be dyne centimeter. Okay, so N1, instead of N1, I will write here 1. Since we have been asked for 1 Newton meter, so here I will write 1 multiply U1. U1 is the unit Newton meter. Should be equal to, I want to find out how many. So I want to find out N2, and my U2 is dyne centimeter. So here it is dyne centimeter. Okay. So I want to find out N2. Once I will be find N2, so I will know that how many dyne centimeter are there. So it will be 1 Newton meter divided by 1 dyne centimeter will be equal to N2. Now I want both of these to cancel each other so that finally your answer will be just a number. So either you convert this Newton to dyne and meter to centimeter, or dyne to Newton and centimeter to meter. Both ways you will get the correct. So as we know that 1 Newton is equal to 10 to the power 5 dyne. So I can write here 10 to the power 5 dyne multiply 1 meter is equal to 10 to the power 2 centimeter, and you have here on the denominator 1 dyne centimeter. So dyne centimeter gets cancelled, and you have the value of N2 as 10 to the power 7. So I will say that in 1 Newton meter, there are 10 to the power 7 dyne centimeter. Agree everyone?
Yes, sir.
Okay. So similarly, I will give you just one more question. If you are able to do that, just look up at that if you can do that. Okay. So here is another question. See, calculate the value of one erg in SI system. So what is one erg?
Yeah, what
Okay.
is it?
See, do you know what is the unit erg represent?
No, sir.
No.
So
Erg is the, yes,
energy.
energy, right? So erg we use for energy in CGS system. This is the formula for energy in CGS system. And we want to convert this to SI system of units. I want to convert to SI system. So I will write the formula N1 U1 equals N2 U2.
You do.
Okay. So N1 U1 I will be taking this erg. N2 U2 I want to take the SI system. Okay. So N1 at the place of N1 I will write 1. U1 should be equal to the erg equal to N2, which I want to find out, and U2 will be joule. Since for the SI system, energy is measured in joule,
I do.
right?
Hmm.
Okay. So now let us see, if I find out the value of N2, then I will get my answer. Okay. Now for that, I want to expand this erg and joule. See, to expand this, we know the formula of work done. Work done is given by force multiplied displacement, right? And this is the unit joule. Isn't it equal to joule?
Yes, sir.
Okay. So if force will be measured in Newton, distance will be measured in meter. So this will be equal to joule. If force will be measured in dyne and distance in centimeter, then what would be the unit?
Erg.
Arcs. The unit would be equal to arcs, right? So here, now I want to convert. So I will write this arc as dyne centimeter. So 1 multiply dyne centimeter, okay, equal to N2 multiply joule can be written as Newton meter. Now, how many of you can perform and tell me the answer? I am giving you 3 minutes. Okay, within 3 minutes, try to find out.
Hmm.
Within 3 minutes, find out. You have already done a similar thing. So 1 multiply dyne centimeter Yes.
So 1 by 10 power 7.
1 by 10 to the power 7. Is everyone getting the same thing? 1 by 10 to the power 7. So can I write that 1 by 10 to the power 7 as 10 to the power minus 7?
Yes, sir.
Yeah. So I can write here 10 to the power minus 7 to be equal to N2. So I have got my answer that 1 UG will be equal to 10 to the power minus 7 joule. Got
Yes,
it?
sir. Yes, sir.
Yes, sir.
Okay. So in homework, I will be giving you similar questions. There will be just 1, 2 questions similarly so that you can find them, convert them in the other units. Okay. For example, I would like you to find out uh, universal gravitational constant in CGS units. What will be the value of universal gravitational constant in CGS units? Can you do that?
Hmm?
Try doing this. This is a part of your homework. So as a part of homework, I am providing you. You have to find the value of universal gravitational constant in CGS units. So you have to find the value of universal gravitational constant, that is capital G. So in SI units, we know the value.
What is it?
In SI units, we know the value of capital G, that is 6.7 multiplied 10 to the power minus 11.
So can I repeat it again?
See, here it's written on the screen. You can see you have the value of universal gravitational constant G. Okay, so
Hmm.
universal gravitational constant capital G is equal to 6.7 multiplied 10 to the power minus 11
Hmm.
Newton meter square kilogram minus 2. Now I want you to find out this value in other unit, in CGS system of units. If we use the CGS system of units, so what this value will be equivalent to. The same thing you have to use. You have to use the same method. N1 U1 equals to N2 U2. The same thing will go. There is only one change. And first of all, you find out for 1. Find out for 1 Newton meter square kilogram minus 2, and then multiply by this number, you'll get the answer. Okay, so I've provided you help also with this homework. Do this. So this is a part of homework. Okay, now let us see how do we perform different measure. Our next part is making the measurement. So how do we go about in making the measurements? How can we make the measurement? Okay, so first of all, a very common method is the direct method. If you are given to find out any length, you go on to measure it directly. So that method we call as the direct method of measurement. Okay. So do you think the direct method of measurement is applicable everywhere? Can we use direct method everywhere?
No.
No. So can you tell me the situations where we cannot use and where we can use? Yes, where can we use the direct measurement? Okay. Suppose you are told to measure the length of a table. So you will be using the direct method of measurement. Yes. Suppose you are told to find out the height of a building. So you can use over there direct method of measurement also. Now, what are the indirect methods of measurement? they are used for measuring very larger distances or very small distance. Okay, so direct methods are limited. If you use direct methods of measurement using a meter, scale, or any other, so they are limited. You have limited means. You have limited objects for which you can apply the direct methods. You have indirect methods which can be used to measure other units or other quantities which are very far off. For example, using the indirect method, you can measure the distance of Earth and Moon, which you cannot measure directly. You can measure the diameter of Earth. You can measure the diameter of Moon. Okay. You can measure the period of rotation of Earth. You can measure the size of particle. You can measure the size of molecule, okay, size of nucleus. So, do you think that to measure the size of nucleus, we use direct methods? No.
Too small.
Okay. So, I hope you have understood about the indirect methods where we can use the indirect. We can use indirect methods for the measurement of length. We can use indirect methods for the measurement of very big distances and very small distances. So indirect methods, they are used for larger distances, for example, sun and moon, uh, width of solar system, size of sun, width of solar system, size of sun. Okay, so these are some of the larger measurements which can be made. Distance between two stars. So for that we need to use this. We have to have some other methods of measurement. We also need for very small measurements. So suppose we want to measure very small measurement. So we cannot use a direct method. For example, suppose I want to find out the thickness of hair, the diameter of hair. I want to find out the thickness of a wire. So those are a very small measurements. So there also, for example, thickness of hair, size of molecule, size of molecule, size of a bacteria. So they cannot be measured up directly. They require some indirect approaches of measurement. Okay. So let us see how we can measure out, how we can find out the different distances. So see, how can we measure the distance of moon, or how can we find out the diameter of moon? Okay. So let us see how can we measure the diameter of moon. This is one of the example. It is also called as the parallax method. So to measure the diameter of moon, so as we know that we cannot measure the diameter of moon directly, we need to use some indirect methods. And for that, we use electromagnetic waves, or we can use laser beams or EM waves to find out the distance between sun and moon and earth to find out the diameter. Okay. So since we have 3-4 minutes left for the class, so is there anyone having any doubt in today's class?
No.
Is everyone able to convert from one system of units to the other system of units? So see here, the measurement of length can be made using direct method of measurement, using measuring instruments, and indirect methods or mathematical methods or chemical methods are also there. So chemical methods are there for measurement of very small distances like the molecular distances. Okay. So they can be measured with the chemical methods. Mostly here in this syllabus, we will be studying about direct and indirect method. So in the direct methods of measurement, up to now we have seen is our normal scale. Even in the direct methods of measurement, we have seen our ruler scale. Apart from the ruler scale, you have other instruments like you have the vernier caliper, which is used to measure smaller distances. You will have vernier calipers.
చేసి
You will have a screw gauge.
ఇది వద్దు నా పాలొద్దు
Yes, yes, Pritham. So while studying further, we will deal with vernier calipers and screw gauges. We will see how the different measurements can be made with the screw gauge and the vernier calipers. So just today, I'll just show you how a vernier calipers look like and how a screw gauge look like. So they have a vernier calipers and a screw gauge. They have a very high approximation. For example, vernier calipers can measure about 0.1 mm. A screw gauge can measure about 0.01 meter, 0.01 millimeter. Okay, so they have a very high accuracy. We can use these instruments even to measure the thickness of a blade. The thickness of a paper can be measured using a screw gauge. Okay, so just I will show you the figures or the diagrams of screw gauge and vernier calipers. So just I will show you the screw gauge. See, a screw gauge. Okay, see, this is an instrument called as screw gauge. You have a circular scale and a main scale on this. So you can see here markings. So we'll see how to use them, how to find out their least counts. Apart from them, you also have the vernier calipers. So let's see vernier caliper also. A similar instrument here, vernier calipers, which you will be using in your school laboratory. So this instrument is called as vernier calipers. It will be used to measure the diameter of a substance.